Designing performance into a suspension system is a task well suited to Rancho Suspension's research and development engineers like William Golpe, the recipient of 2 prestigious SEMA awards for his design work on Ford Rangers and Broncos. William, how involved was it for you to design a suspension system for this Ranger with Ford's twin I-beam system?
Well, we went in with a longer than stock radius arm. We went in with a new sway bar cross-member mounting system. We had to go in with new lowering beam brackets, radius arm brackets, urethane rear bushings, a new steering arm, and coil springs.
It's pretty obvious to see there's a difference between the stock radius arm and the Rancho.
It sure is. As you can see here, it's approximately 11 inches longer than the stock arm. We gained this knowledge pretty much from our full-size Ford kit. What this gives you is increased wheel travel, improved front-end geometry, better ride on and off the road.
And all your hardware looks like it's been beefed up here. The bracketry looks pretty heavy-duty.
Yeah, let me go into this cross-member, which adds integral strength and mounts the sway bar. We didn't want to lose the sway bar for street performance, so we made this tubular crossmember. Also, on this tubular crossmember, we mounted a support tube that ties in with one of our new frame brackets. That's to help keep the factory crossmember from wiggling. It gives added stability to the front suspension.
And the beefed up performance sure looked like it paid off today from what we've seen.
Yeah, we've gained quite a bit of increased wheel travel, which gives a better ride on and off the highway.
You're going to have some different things involved when you go to a Chevrolet. Can you show us?
Sure, come on over. Thanks, Ron. Jim, as you can see here, we have the Chevrolet independent four-wheel drive suspension system, which is much different from the Ford systems we've seen before. It has an upper and lower A-arm. What we did at Rancho is we went in with a new design A-arm made out of tubing. What we had to do was change the ball joint mounting area to get the proper angulation. We've also gone in with urethane bushings. Also in this kit, we've gone in with a computer-aided design torsion bar, which gives high performance and low stress.
Sturdy stuff here.
Also, what we've done in this kit is gone in with the double shock mount, and what we have here is a frame bracket for the double shock. Connecting double shock into the system of the frame, we've gone in with over-engine bracing. That will connect the right and left frame rails together for better stability.
Okay, we've seen what you have for Ford and for Chevy. Have you got anything else in the works?
Yeah, we also have a late model independent Toyota system, which is much like the Chevrolet system, consisting of new A-arms, torsion bars, and rear add-leafs.
Rancho's rear add-leaf springs are also used in conjunction with both the Ford and Chevy suspension system. Folks know I like to take a look at the pieces and the parts, but this is the place to go for a test run. You going to take me out for a test spin?
Yep, let's go.
Let's do it.
No one can better describe how Rancho transforms test results and design technology into a finished lowering kit better than their award-winning research and development engineer, William Golpe.
What we have here is Rancho's new designed tubular lowrider axle beam for a Ford Ranger two-wheel drive. As you can see, Rancho has chosen to go with tubing rather than the I-beam construction that Ford has. What we've done is actually lowered the ball joint geometry 3 inches to actually lower the vehicle 3 inches and yet allow easy alignment. We retained the stock coil spring to give you that smooth factory type ride. All right, let's do a direct comparison between the Rancho beam and the stock Ford beam. As you can see here, the offset in the ball joint area. That's how we obtained our 3 inches of lowering. What we've done is raise this area 3 inches for where the ball joints locate in. Let's talk about the tubular design construction that we talked about earlier. This affords a lighter beam, which gives us less unsprung weight than does the factory beam. Down here, we have the Rancho DuraCrush urethane bushing. Gives long life and resist elongation. Back of the Ford Ranger, the leaf spring is normally mounted on top of the housing. To lower the vehicle, it's just a simple matter of putting the leaf spring on the bottom side, utilizing the design bracket from the Rancho system. This bracket is engineered to give proper driveline pinion angulation and drive shaft length. The Rancho Ranger lowrider system lowers the front of the vehicle approximately 3 inches and lowers the rear approximately 4 inches. This system allows the Ranger to maintain the originally designed ride with a lowered street look. In contrast to the Ranger lowrider system, we have here a C1500 late model lowrider system. As you can see, we utilize a new computer-aided design leaf spring assembly rather than extensive bracketry to lower the rear of the vehicle. We get low stress, good ride, and still maintain some load capacity. The spring also utilizes the famous Rancho DuraCrush red urethane bushings. We've lowered the front of this Chevrolet C1500 late model Chevy by replacing the stock coil spring with a Rancho computer designed front coil spring. This spring was designed to give good, comfortable on-highway ride, and because it is computer designed, it has low stress. That translates into long life. What we have here is a typical front frame section and front suspension from a late model Ford 4x4 independent suspension system. As you can see, it consists of a left axle beam, right axle beam, radius arm on the right and a radius arm on the left. The travel on this, as some people think, is in a up and down movement, or this way with the radius arm. It's really in a triangulated movement this way, which I can demonstrate. As you can see, the kingpin axis is traveling in this direction. What that does is on this bushing here, this bushing now goes through a torsional movement. What we tried to do here at Rancho was eliminate some of the movement, which would eliminate stress, which would thus give us more wheel travel and a smoother ride. In order to do that, we had to lengthen the radius arm approximately 15 inches. What we have done by doing that is eliminated stress here, eliminated some stress here, which will give us more wheel travel, better on and off-road performance. This is a typical aftermarket lift kit. The reason I say lift kit is, in our opinion, unlike what we do here at Rancho, this is not a designed and engineered system. First off, I'll show you right here this brightly cadmium plated bracket. One of the problems that may occur from this CAD plating is hydrogen embrittlement, which can cause cracks and fatigues and possible splitting of the bracket. Come over here, and basically the same problem exists here, and you'll notice this bracket is piggybacked into the stock bracket. Then we come here and you'll notice that this particular system retains the stock radius arm, which is giving us the same stock geometry, the same stock triangulation on the bushing here, which can lead to a binding condition. What happens now is this bracket has been elevated from this point to this point, and it creates a giant lever arm. We still have our torsional move, but now it's telegraphed through this bracket all the way down through the frame with the possibility of cracking the supporting member of the chassis. We come over here, you'll see that the radius arm has a drop bracket. This too can cause problems in some instances.